Okay, today we're doing biconditional statements. So we already did conditional statements, so now we're going to do the biconditional. You should have this paper in front of you. A biconditional statement combines a conditional statement, if P, then Q, with its converse, if Q, then P. So, for example, the conditional statement, if the sides of a triangle are congruent, then the angles are congruent. Converse, if the angles of a triangle are congruent, then the sides are congruent. This is two true statements, by the way. The biconditional will be the sides of a triangle are congruent if and only if the angles are congruent. So in this case, notice that the if and then aren't in there. In the middle, it's only a if and only if. Okay? So this one says, Lindsay will take photos for the yearbook if and only if she doesn't play soccer. So the directions say write the conditional statement and the converse within each biconditional. So right now they already gave us the biconditional. I know it's the biconditional because it says if and only if. Okay. So my conditional statement would be if Lindsay takes photos for the yearbook, then she doesn't play soccer. So that'd be my conditional. So then my converse would be if Lindsay doesn't, so remember converse, you flip it. If Lindsay doesn't play soccer, then she takes photos for the yearbook. So that's my conditional. That's my converse. Okay, this one says the measure of angle ABC equals the measure of angle CBD if and only if ray BC is an angle bisector of angle ABD. So remember, I'm changing them to the conditional and the converse. So if the measure of angle ABC equals the measure of angle CBD, then ray BC is an angle bisector. Remember to press pause if y'all need me to press pause if I'm writing too fast. My converse would be if ray BC is an angle bisector, then the measure of angle ABC equals the measure of angle CBD. Remember, for the converse, I switch the hypothesis and conclusion. Okay, on 3 and 4, we're going to just write the biconditional. It says for each conditional, write the converse and biconditional. We're just going to write the biconditional. So if you can download 6 songs for $5.94, then each song costs 99 cents. So it will be you can download 6 songs for $5.94 if and only if each song costs 99 cents. Okay. Okay, let's look at 4. We're going to change it to a biconditional. If a figure has 10 sides, then it's a decagon. A figure, so pretty much you're taking off that if at the beginning. A figure has 10 sides. And then where you see the comma, you change it to if and only if and only if it is a decagon. That's all a biconditional is. Okay, let's talk about the validity of the biconditional. So, a biconditional statement is false if either the conditional statement is false or its converse is false. Okay? So, if the conditional or the converse is false, then it's a false statement. Definitions can also be written as biconditional. So circumference is the distance around a circle. A measure of the circumference a measure is the circumference if and only if it is the distance around the circle. Okay. All right, so let's look at these examples. We're going to say if it's true or false and give a counterexample. Students perform during halftime at the football games if and only if they are in the high school band. Students perform during the halftime at the football games if and only if they are in the high school band. So would that be true or false? Hopefully you said false. Because who else performs during the halftime show? Is it only the band? It could be eaglettes. It could be the color guard. Okay. So those are counterexamples to make this statement not always true. Okay. Let's look at 6. An angle in a triangle measures 90 degrees if and only if the triangle is a right triangle. An angle in a right triangle measures 90 degrees if and only if the triangle is a right triangle. This would be true. Because if it has a 90-degree angle in there, that means it is a right triangle. 7. A equals B and B equals 3 if and only if A, B equals 12. So A times B, so 4 times 3, that is 12. So A equals B and B equals 4 if and only if A, B equals 12. So that'd be true. Okay. All right, you're going to do the practice paper that you have, and then after that, we're going to do the algebraic proof notes. All right, thank you.